Alright folks, let's look at the application problem that has to do with vectors. Still section 6.4. Have you ever seen somebody tie a rope to two trucks, have them go in kind of different directions to pull a tree up in a certain direction or something? Well, that's what we're going to study today. It's called resultant force. Resultant force. This is a good physics problem for you. So if I have this stone, let's suppose there's a rope tied around the stone, and the farmer is trying to clear his field, and the farmer's going to pull the stone this direction with his portion of the rope with 200 pounds of force. Okay? 200 pounds of force. Let's suppose we have a horse pulling in this direction at 1,000 pounds. At 1,000 pounds of force. So the first thing I notice is this is the parallelogram rule for vectors. Okay. So what that means is this: the resultant force will be the force that's applied this way. So whatever direction that is, and the direction is always measured in an angle, so we'll call that angle alpha. So whatever direction this is here, okay, whatever direction, this will be the direction the stone is tugged because of the force of the farmer and of the horse, and the magnitude of this particular vector, we'll call it B. The magnitude of B here will be the force at which we're moving it, okay? So let's find the magnitude and let's find the direction. Now we were told in this problem that the horse was pulling at an angle from the farmer of 50 degrees. Of 50 degrees. Okay? Now if this is alpha, the direction that we're pulling is alpha. If this is alpha, that means this would be beta. Beta is always opposite B. So this would be A, and this would be gamma. Now, from my rules of geometry, I know automatically that this right here is 130. Okay? Because those two angles have to add to give you 180. They're supplementary angles. Alright, well, I also know from my rules of parallelograms from geometry that this angle that's 130 is the same as angle beta here. So angle beta is 130. So I can very easily find the resultant force, or B. B is our resultant force. I can very easily find that now using my law of cosines, because if you remember, the law of cosines is B squared equals A squared plus C squared minus 2AC times the cosine of beta. This is our law of cosines. How did I know? That's the question all of you are going to ask. How did I know to use the law of cosines? Well, look, folks, we're given this side. We're actually given this side. Because this is a parallelogram, I know that this is 200. We found this angle. Side, angle, side. Side, angle, side is a law of cosines problem. Okay, so remember back to the law of cosines. So I can solve this very easily, plugging in my 1,000 for my C, 1,000 squared. My A here is actually 200. I actually wrote those backwards. Okay, minus 2 times 1,000 times 200 times the cosine of beta, which is 130 degrees. Make sure your calculator's in the right mode. And so once you solve that and take the square root of both sides, you'll get your B to be 1,100 pounds, approximately 1,100 pounds. So I know this right here is 1,100. So that is the force, okay? That is the force at which I'm moving that rock in that direction. 1,100 pounds of force. Okay? So, now what direction am I actually moving it? So in other words, what is alpha? Well, notice, we're looking for alpha. We know side A. We know angle B. And we know side B. So if I know angle B and side B, and I know side A, how can I find this angle alpha? Well, notice this is a side angle problem. Side angles are law of sines. Now, you wouldn't even have to know it's a law of sines, a side angle problem, if you just kind of realize what the law of sines is doing. It's really relating the sides. So what formula, you could have really asked yourself, instead of doing side angle, you could have really asked yourself, what formulas do I have that relates angle beta and side B, side A, and angle alpha? Well, that's the law of sines. So sine of alpha over A equals the sine of beta over B. And so we don't know sine alpha, so that's what we're looking for. But we do know A. A is 200. And we do know beta. That's 130. And we do know side B now, which is 1,100. Alright, so cross multiply. Now we're trying to find alpha. So what are we going to have to do, folks, to find sine alpha? Well, we need to cross multiply and divide first. And so that gives you sine alpha equals 200 times sine of 130 all over 1,100. Now, this is where some of you had the questions. When do we use the inverse? Well, this is when you use the inverse, because you're trying to find the angle. So to find alpha, we have to do the inverse of 200 times sine 130 all over 1,100. So alpha, when you punch that out, our alpha is going to be 8 degrees. And there's our answer. We have the direction that we're pulling it, and we have the force at which we're pulling it. Now, this particular problem is in your book. The word problem part of it is page 391 at the bottom. I would look at that and read that problem with the word problem and try to draw it. That is going to be the hardest part, is drawing it correctly. If you can draw it correctly, now they actually had this one drawn for you on page 392. But if you can, when you're working on one of these, if it's not already drawn for you, draw it. Because if you can draw it and see it like we have here, it's going to make it a lot easier for you. Resultant force. All right, be expecting one of those. Have a good day.